Welcome to lesson 11.3 in your statistics take-home unit. Today we're going to talk about some measures of central tendency. Measures of central tendency are mean, median, and mode, which are three things that I know you've all worked with before in middle school and elementary school. Today's focus, however, of those three things is that you're going to think about the mean and the median of data. Okay, we're also going to talk about something called outliers today in this lesson. So let's read. In our day-to-day activities, we deal with many problems that involve related items of numerical information called data. Statistics is the study of sets of such numerical data. When we gather numerical data, besides displaying it, like we did with the histograms, the box and whisker plots, and the dot plots, we often want to know a single number that is representative of the data as a whole. We call these types of numbers measures of central tendency. The two most common measures of central tendency are the mean and the median. So let's explore the mean and the median in exercise 1. Exercise 1 says a survey was taken amongst 12 people on the number of passwords they currently have to remember. We all have passwords for things, Facebook, email, we all have to remember them all, right? So this survey asked people how many different passwords they have to remember. The results in ascending order are shown below. State the median and the mean number of passwords to the nearest tenth. So let's first talk about the median. Okay, so the median is the middle number. So the median is the number that falls directly in the middle. Let me rewrite that. Number that is directly in the middle. Okay, it's really important for the median that the data is in order. So you have to order the data first to find the median. So when I look for the median, I'm going to go see where the exact middle is. So here's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So I see that this 2 and this 3 are the numbers directly in the middle. Okay, so these are the middle two numbers. So the median would be 2 plus 3 divided by 2. So I want to find out basically what's halfway between 2 and 3, and halfway between 2 and 3 is 2.5. So my median is 2.5. Okay, it's that number directly in the middle. So the median is that middle number. The other measure of central tendency we're going to talk about is the mean. The mean is, in other words, you call it the average of all the data. So to find the mean, you add up all the data, add up each point, each entry, and then divide by the total entries. Okay, so we're going to add them all up. So I'm going to have 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 4 plus 6. And I'm going to divide that by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is what we had from our original problem. And so when I do this on the calculator, the very top is going to add up to 29. Divide that by 12, and I end up getting 2.416. And they want us to round to the nearest tenth, so that means that I need to round this to 2.4. So this 2.4 is our mean. Notice that the two numbers are pretty similar, 2.4 and 2.5. That's not always going to be the case. Sometimes the mean is larger, sometimes it's smaller, but these are measures of central tendency, meaning that, well, the average person has to memorize 2.5 passwords, okay? So let's take a look at this further when we're talking about analyzing data with the median and the mean. So exercise 2 says students in Mr. Okafor's algebra class were trying to determine if people speed along a certain section of roadway. They collected the speeds of 20 vehicles as displayed in the table below. So we have 20 vehicles, but the weird part about this data is there's only 1, 2, 3, 4, 5, 6, 7, 8 different speeds. So that means that some of the vehicles were driving the same speed through the area. So the first thing that we're going to do is to find the median we have to order our data. We always have to order it. So I'm going to go over here, and there's one person at 29, so there's 129. There's 2 people going 33. There are 4 people going 34. I'm going to separate these by commas. So 1, 2, 3, 4. There were 5 people going 35. So 5 35s. There were 3 people going 36. There were 2 people going 38. And there were 2 people going 39. And there was 1 person really going fast at 54. So then to find the median, I just find that very middle value. And so I kind of work from the outside in by underlining. So there's 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, and then here are the 2 in the middle. Because both of them are 35, that means that my median is 35. So my median is 35. It's that middle value, okay? So the median speed was 35 miles per hour, okay? Now I'm going to find my mean. My mean is the same as finding my average. So that means I have to add up all of these numbers here. So I would do 29 plus 33. And I'm going to simplify this a little bit. See how over here this is 33 and I've got 2 of them? So this is like saying 33 times 2. This is like saying 34 times 4. So I'm going to kind of simplify this for myself a little bit and save some space and write this as addition and multiplication. So I've got 4 people going 34 miles per hour. I've got 5 people going 35. I've got 3 people going 36. The 2 going 38. 2 people going 39. And finally that 1 guy going 54. I'm going to add that all up and then divide it by 20 because that's how many total vehicles I was getting my survey from. When I do this math and add up the top, you know, this is something to do with a calculator. I'm not going to show it by hand on here, but if you put all this in the calculator, you'd have 722 on the top divided by 20. And when you do this in your calculator, you get 36.1 miles per hour. So this is your mean. So my mean, my average speed is 36.1, but my median speed is 35. So now we're going to talk about analyzing this information a little bit. So look at letter B. The speed limit along this part of the highway is 35 miles per hour. That's the speed limit. Based on our results from A, meaning we have our mean right here is 36.1, and our results for our median, which was 35, is it fair to make the conclusion that the average driver speeds on this highway? Can we conclude that here? So that's what this is saying. Can we say the average driver speeds? Can we agree with that? Well, according to the mean says 36.1. So you first look at this and you think, well, if the average speeder is going 36.1, the 36.1 is bigger than 35, so it kind of makes sense they're speeding. But if we take a closer look at the actual data, we can see that out of 20 drivers in our data set, only 8 of them were going over 35 miles per hour. So this chunk right here, these are the ones that are speeding. We have 8 of them. Whereas the ones before that here, 12 of them were following the law. They were going either 35 or below. So based on our data, we can say that no, most drivers were following the law. So if this is true, then why do we have a mean that's greater than what most of the people are doing? Well, that's what we're going to talk about with this number right here. Do you see this 54 miles per hour? This 54 is called an outlier. Because do you see how 54 is such a larger number than all of the others? You've got this one guy who's going very quickly. going very quickly, and it's throwing all of our data off. That one little number is making our average bigger than it should be. This is called an outlier. When you've got one number that's just completely different than all the rest of the numbers, it's going to change your mean and your median. Okay? So let's take a look at exercise 3. When conducting a statistical study, it's not always possible to obtain information about every person or situation to which the study applies. Unlike a census, in which every person is counted, some studies use only a sample or a portion of the items being investigated. When a sample is taken from a group, it's vital that it be fair. In other words, that the sample reflects a general population. So we're going to talk about something called bias in this example. So example 3 says, to determine which television programs are the most popular in a large city, a poll is conducted. So someone's going around and asking people what their favorite TV shows are. Okay? Outside which of the following locations would the interview be most likely to find a fair sample? Explain your choice and why the others are inappropriate. So let's say here are the 4 places that you're going to go to survey what people's favorite TV shows. Well, let's say the first place you go to is the baseball stadium. What kinds of people go to baseball stadiums? People that like sports, right? So if you ask them what their favorite TV show is, what are they probably going to say? They're probably going to say ESPN. So going to a sports stadium and asking people would not be fair because you're going to a place that has generally people that like sports. You're not picking random people that might like anything. So this would not be a fair place to go. If you went to a concert hall, what kinds of people go to concerts? Well, the kinds of people who like music. So if you ask a lot of people at a concert hall what their favorite shows are, they'll probably say something like MTV or a music station, something like that. So this wouldn't be fair either because only certain types of people go to concert halls. If you went to a comedy club, what kind of people go to comedy clubs? People that like comedy, people that like funny TV. So those people are probably not going to list dramas or horror TV shows. They're going to list comedy shows, so this wouldn't be fair either. The only place to get a fair sample of people is a place like a grocery store. Everyone goes to the grocery store, right? Everyone has to eat. There's no bias in going to a grocery store, right? So this would be a fair place to go get a sample, right? Is the grocery store. Okay? Everyone has to go to a grocery store, so it's pretty fair to ask for a poll about your favorite TV show. Okay? So this is called bias, right? We want to eliminate... sorry, this should say fair place. We want to eliminate bias in our statistics studies. So that leads us to exercise number 4 about bias. So exercise 4 says, Truong is trying to determine the average height of high school male students. So if you walk into a high school, what would the average height of any given kid, of any boy in the high school? Because he's on the basketball team, he's going to use the heights of the 14 players on the team. Right? So here are all the heights of the basketball players. Notice that they're already in order. They're already in order, so we don't have to order them. So the first part says, well, first find the mean and median for this data set. So remember, the median is that middle number. So when I go to my median, I'm going to go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and I see that these two numbers fall right in the middle. So that's going to be my median, the number between those two. So my median is going to be the 74 plus 75 divided by 2, which is 74.5. So this is my median. Okay, now let's find the mean, which is the average. So the mean is, we're going to add all these up. 69 plus 70 plus 72 plus 72 plus 74 plus 74. We're just adding all of these up. And you don't have to write this out every time. I'm just writing it out to show you what it would be, because it does take a lot of space. After I add all that up, I'm going to divide it by how many players there are on the team, which was 14. And when I do this calculation on my calculator, I get 1,044 when I add up all of their heights, divide it by 14, and I get a mean of 74.6. So this is my mean. The mean and the median are actually very close in this example. Okay? So letter B says, is the data set a fair sample used to determine the average height of a general high school student? Is it fair? And the answer here is no. This is not fair. Why isn't this fair? Because basketball players tend to be taller than most other students in the school. Basketball players are generally tall. So if you're looking for the height of a high school population, this isn't a fair place to go. Okay? This would overestimate how tall an average person is. What would be a better way for him to get this sample? So a fair way to figure out the height of all of a typical student would be to ask every student in Ms. Pennington's algebra class. Right? Every student has to take algebra, so we could just ask a sample of students in my algebra class. Right? Don't ask basketball players. They're going to be tall. You're not going to get a fair sample. Okay? And finally, the last exercise is going to talk about this idea of outliers. So data sets can have members that are far away from the rest of the data set. These elements are called outliers, which can result in a mean that does not represent the true average of the data set because one number is really off. So exercise 5 says, in Mr. Pedrovic's advanced calculus course, 8 students took a test. Their grades were as follows. Calculate the mean and median first. They're already in order. Always pay attention if they're in order. So now I just have to find the mean and median. The median would be me going 1, 1, 2, 2, 3, 3, 4. So here are the two median numbers, 85 plus 87. Divided by 2 gives me a median of 86. And my mean is going to be 45 plus 78 plus 82 plus 85 plus 87 plus 89 plus 93 plus 95, all divided by 8. And that means my mean is going to be 654 divided by 8 to give me a mean of 81.75. Okay? So usually the mean and the median should be pretty close together, right? But notice that 81.75 is way far off from the median of 86. That's a big difference between those two numbers. So what is causing that problem? This number right here. This 45 is an outlier. Every student scored almost an 80 to a 90 on this test, except for this guy who scored a 45. That is a big problem, right? Most of the data is in the 80s and 90s, except for one, the 45. This is called an outlier. Oops, I spelled right. This is called an outlier. It's a number that lies outside the normal part of the data. So finally, our last question says, which value, the mean or the median, is a better measure of how well the average student did? Well, the median is definitely the better score, our better measure of central tendency than the mean. So the median is better. And to explain this, oh my gosh, my pen is being crazy. Let me write. The median is better. Okay, and you know, the way we can explain it, so we can say the score of 45 brings the mean down to a much lower point. It's kind of like if you've got someone on your team and they're doing really poorly, or they break a leg or break an arm or get injured, it's going to bring your entire team down. By one person having an injury or something, it brings your whole team down. So the median in general the median in general is a better measure of central tendency when an outlier is present. If there's no outlier, then usually the mean is great when an outlier is present. The mean is usually great, but if there's an outlier, the median is much better. Okay? So this is your lesson on mean and median and thinking about bias and outliers in your data. Okay? So please take your fluency seriously and really take the time to think about the data. This is not the only math involved here is calculating the mean and the median, but there's some critical thinking skill here, asking yourself what bias is, what's fair, what's an outlier. Okay, so take the fluency seriously when thinking about your answers.